Hello again. It's now time for us to talk about how to calibrate our model. So here's another view of the model state diagram drawn in a slightly different manner for you. Um, we're going to have this notation here, just basically where we talk about an action on the state or a decision. And then if we actually are going to change something, we can have that sort of, this is the result of going across that arc. All right, so we start and we'll set I to 1 is basically. And so we're going to view summary 1 because I is 1. And we're going to spend some time in here. And that's one of the things we're going to need to figure out how to calibrate is to estimate the amount of time spent in each state. So you're going to decide whether or not to click or not. And that's the other thing that we're going to have to model are these decisions. And so we're going to have to figure out how do we set this and model that, this calibration aspect. If we do decide to view a document in our model, we click. And there's nothing other than the decision to click. And then we're viewing document I, in this case 1, where we're at. And we spend some time here and we make a decision about whether or not that document is relevant or not. If we decide it's relevant, we go here and we'll advance ourselves. We're going to basically, when we get back to here, we're going to view the next summary in the result lists. Effectively, we're hitting the back button and we're going to increase our gain. All right, we're going to add to it. Now, for us, gain here in the model very much is the number of relevant documents that a user has decided to save. So when you decide it's relevant, it's a decision to save the document. The user study that we use to calibrate this model actually literally has a button in it that a user says save, and then they can choose, they can undo that and choose not to save it if they change their mind before moving on. So absolutely, that's literally what we're talking about. A user has made a decision that this is relevant and should be saved, all right? Because that's the model that we have. We just talk about gain in an abstract sense, but the literal one here is number of relevant documents found. I'll note that it only makes sense for this sort of model to talk about this cumulative gain in situations where it truly is something that accumulates in a sensible fashion. So, number of relevant documents saved, that makes sense that you can accumulate that amount of gain. There could be other things that you could measure, maybe on some sort of scale that could accumulate. But anything that you're doing you're going to talk about cumulative gain, it should make sense to add one item to another item such that the sum of those items has some meaning to it. Certainly, the notion of number of relevant documents saved is a very sensible notion of gain. And then this is the process you're following. And then, of course, you can make a decision if you're viewing a summary that you're not going to click. And this also advances you then to the next summary. And so we have time spent here, a decision made to click or not click. Then we have time spent here and a decision relevant or not relevant. All right. And then we move on and continue on. And so we've got time, and 2 types of decisions to make to model in to calibrate in our model. All right. So we want to keep things simple here. We can always end up with a fancier model as we progress on, but definitely gonna keep this simple for now. All right, so let's talk about this. So we're gonna need to collect some data to calibrate a model. I already mentioned that we used a user study, but let's talk about this in a little bit more detail. How to collect data. So this is how to collect data for calibration. All right, we have some options. One, you could have a live search engine. The pro of this is it's definitely real usage. Okay, there's no doubt that this is actual behavior of people. It's a live search engine, and this is the thing that you originally started off observing and so forth. And so anything you can get from it, you know it's not some fake scenario that you've brought people in or whatever. But there are some problems with this. It's hard to know for these users what is relevant or not. And the user interface is very different than our simple model. My pen is dying. Time to toss this one for sure now. All right, grab another one. So now you might say, well, wait a minute. That's a problem with our model. The live search engine is what the live search engine is. That's absolutely true. But you've got a balance here, which between what's going on when you calibrate. You could get measurements on the complex search engine interface and have a mismatch to your simple model. All right. Or you could get very good measurements on your simple model, on an interface that's matched to your simple model. So you won't have a mismatch between the measurements and your model. Now all you have then though is a mismatch between your model and the actual reality. I think it's potentially easier and better to say, well, in my simplified model, I had people use it, and now I've got really good measurements of them on the simplified model. And let's see how that compares then to the more complex reality of the world we have, as opposed to, I took measurements here, they're complex to get, they don't really necessarily fit my model, I have to do strange things to sort of stick them into my model. I would worry that might cause more issues with validation than the mismatch between my model and the reality. So in other words, it's probably a little bit better to get measurements off of the simple model and then see how close we are to reality, as opposed to try to measure reality and squeeze those measurements somehow into the model. But I don't know for sure. I'll be honest. So, but there definitely, it is complex. Let me just say that it's complex to get the measurements off of the real search engine and into the model. It's a non-trivial thing, partly because we don't know what's relevant and not, and so forth and so on. We're not in control of this system. Another alternative, besides the live search engine, is what I've alluded to, which is a controlled lab study. All right. Now, the pro, basically, if this is, absolutely, we can go and we can restrict our user interface and the tasks that the users do, and we can know what's relevant and not, etc. We're going to build it, and our users are going to tell us, I think this is relevant. We also are going to have our own judgments about whether things were relevant or not. Like, we're in complete control here. Well, the problem is it is less realistic. Absolutely. People aren't under their normal time pressures. People aren't behaving normally, in like switching between the search engine. You know, I mean, there's a whole bunch of other stuff there's a lot of loss of realism here. One of the other issues is the search topics are given to people. I mean, these are not their search topics. It's not something that they are in control of because we're controlling everything. And so that's unrealistic. The UI is definitely simplified, etc. There's a whole bunch of stuff there that affect this realism. But we gain all this control, and we're able to really make sure that we make very good measurements about what is actually happening on it. And we've seen, by the way, both of these done. We've got research papers where people have extracted data from live search engines and used those to calibrate models, and we have a controlled lab study. What I'll talk about today is actually a controlled lab study that I conducted with CP Jethani back in 2010. It was a study that we did, and in this study, one portion of it, we gave people a search task, and they would be shown a page, and we would have on this search page, you know, basically we would show them, you know, the query up here at the top. There'd be a nice display of that. Description of it, you know, what this thing is. We then would give them more details and further instructions in a little panel here. I believe actually this was a short version of the topic, and I believe this actually was the topic narrative. I actually should check and find out. I'm just going to do that really, really quickly. All right, I'm off the screen and checking and seeing what this is. And I'll tell you in just a moment. This is very weird. Not on the screen. Yeah, that's actually what it was. I apologize. I should have actually done this a little bit better. Up here were actually directions. They were kept short and so forth. And then this actually, yes, this was the topic, and it was written. What we did is we took the narrative and the description and we sort of rewrote them into one explanation for the user about what it was they were looking for. And then what we did is we had you know, our results here. You know, they would have a title and a snippet and so forth, and we had this, and we had a total of 10 of these on the page. All right, and then at the bottom, and so what you could do is as you actually there were not 10 of them. This actually continued on in some way. I really wish I could remember. Oh yeah, so sorry. I seem not to be as prepared as I wanted to be here. Anyway, next 10 results. There was a link at the bottom of the page where you could actually click and say, give me another 10 results, and it would give them another 10 results and another 10 results. So you could keep going through on down the rank list. And so yeah, we showed them 10 on a page. They could get another 10 results. When they actually do click on one of these, it would take them to a page, and they'd see up here, they would have a chance to basically press a button to say they wanted to save it as relevant, and then they could basically change that to, you know, basically not save it, so they could reverse this behavior. They would usually see a title and then all the text of the document here. All right, and so the idea is when they decided to save it, then they could hit a back button on the page and they could come back to the search engine results page. Now, the users never actually enter a query. We produce these search results for them. We actually keep them, they're completely controlled. What we actually did is we showed them 2 different setups of these search results. In one setup, 6 out of every 10 were relevant documents, and in the other setup, 3 out of 10 were relevant documents. And so as they worked on different tasks, different search topics as they were part of this study, they were exposed to 2 different levels of precision. And this precision was kept uniform for the length of the search results. So that's not entirely realistic. It was not something that the users seemed to notice. And we were able then to be able to record all their behaviors on these things. Now, we don't know what they were looking at a given time. All we were able to do is record all of their clicks. We also had mouse over data, but that actually was not very useful to us in our analysis. So all of our analysis ends up on being they viewed a page at a certain time, they click on something at a certain time, they're here for so long, they click a button here, they come back, we know they're here, they're spending more time here, and eventually they would then, there was a timer and they worked for 10 minutes. So they said, you know, you're gonna look for relevant documents for 10 minutes. When the timer is up, you're done with the task and we'll give you another one to do. And you'll look for relevant documents for another 10 minutes. And they were instructed to pretend as though they had done this search and to behave as normal. But yeah, they had to work for 10 minutes. This is definitely very much that's a long time to look for relevant documents, but it is very much sort of stimulating the effort that would be required if you really were working on wanting to obtain many relevant documents. One of the things it allows us to do is collect a fair amount of data of user behavior as well. So there's trade-offs here. We don't really know from this study like how many documents people want to find. But we were able to collect certain things about their behavior. And so this is the way it was set up. We picked a subset of search topics from Truck Track, very similar to what you're working on with the LA Times. We ended up bringing in 48 users. They went through all these topics with the different conditions with these precisions, and we recorded all of this data. All right, so that's the basics. I have uploaded the research paper that talks about this, and as well as a presentation that has slides so you can actually see more of what I'm actually talking about. If you go online, I'll talk about that at the very end of the lecture and tell you what that reading is that you should actually do. All right. Okay, so I actually should pause here for a moment, because now you're at that point where you go, wait a minute. So he's teaching us his work? Yes, I am. So this notion of evaluation, of observe, model, and predict, absolutely is not just information retrieval. It's widespread in the notion of how we can go about doing science and industry, things in industry, and how do we improve and model systems and so forth and so on. What we have here is it being applied in information retrieval evaluation, which has not typically been done, actually. Typically, there are other effectiveness measures and approaches, and we will talk about them. The work here that I did with Charles Clark over in the School of Computer Science really is one of the earlier works. It's not the earliest work, but it's one of the earlier works that we have in the field that says, no, let's actually try this for information retrieval evaluation. Let's really build a model and calibrate it and then validate it based upon actual user behavior and use this model then to make predictions of user performance in an offline evaluation measure. So we did this and got it published back in, so the user study was 2010, that there was some work that got published. Then we wrote up this work, and that was in 2012. And yes, now it is 2021 when I'm giving this lecture right now, so a good 9 years have gone past. Have we stood the test of time? Well, the work has continued to be cited. It did earn at the time in 2012 Best Paper Award, so it was acknowledged, and it seems to have collected these citations and have done fairly well. That being said, I do not know of widespread usage of this notion of evaluation that I talk about, and I think that is largely because of the amount of work that it involves. It does take the notion that you're going to take the system that you're using, your search system, you're going to observe those users, you're going to devise a model for it, you're going to calibrate that model, validate it, and then make sure that you can use it for predictions. And that's not a trivial thing to do, just as it's not a trivial thing to go in and model a process in a factory that you want to improve. That takes a considerable amount of time. And I think people are more inclined to say, well, we have these existing evaluation measures. Yeah, they don't tell me I need to calibrate them, and they use them without calibration. There are concerns about what is the notion of that. Are the measurements they're improving, are they observable by users? Do they understand what the changes are? There's a whole bunch of things there, but certainly out of the box, those are really easy. You just use them. And you probably get a decent signal off of them. But what you don't get is a prediction of perhaps percent improvement that could be observed by actual users. So again, yes, I'm showing you an example of this, how to model things based upon our work. There are other people who've done this as well since then. So this is not a one-off thing. These are perhaps not the most mainstream yet of methodologies. We will talk about other ones that are more mainstream, but I do think that long-term that approaches like this are where the field is headed. I think it's the right approach. And I think the important thing to keep in mind really is that you might very well work on systems that don't fit an existing model well. So why would you use an existing evaluation measure that's based upon some model of usage and behavior that doesn't fit your search system or your information system well? If it doesn't fit it well, you're going to get a poor or not very good correlation between your estimated performance and actual changes in what's perceived by the users. So this is a general purpose methodology that you can apply to any information system, any search engine, to say, look, we need to find a way to model it so that we can make predictions in an affordable, efficient manner that then hopefully we can try out with the actual users on the live system. If there's an existing measure that works well, great, use it. But when there's not, it's time to go to the work to devise a new measure, to do your observations, to do your modeling, to do your prediction. This is the only way that you're actually going to be able to get good predictions about what is happening if you have a different type of system. And I actually believe that there's a lot of people out there using search, especially in e-commerce and other areas, that the existing measures are only a rough approximation to what you need. And these companies would actually would benefit from their own customized effectiveness measures. All right, that was a long time with me talking in front of a blank whiteboard, but I felt like that was time to say those things. All right, so let's talk about modeling time. All right, to model the time spent viewing a summary. So that's in that first state. All right, basically, what should we do? All right, so again, we're in the world where I've run this controlled user laboratory study. I've measured all these clicks that people have done doing these tasks. You know, I'll tell you, the easiest thing to do is do some sort of average. Basically, come up with some single number that you're going to do and say, this is the number I'm going to use for how long someone views a summary, and just use that number repeatedly. All right. A harder approach is to model the distribution of time spent looking, or time spent viewing a summary, so that we can then use this for a stochastic simulation. So we're going to simulate things, but we understand that the times people spend looking at the summaries are drawn from a distribution because there's this variance in the system, and we should actually model this variance. We have a later work where we have done that, stochastic simulation of time-biased gain. And you could look at that if you wanted to for more complex. And of course, you can even do more and more complex ways of modeling the amount of time people spend looking at summaries. You could take into consideration all sorts of features and other sorts of things about these summaries to try to more accurately predict, you know, for a given search engine, how long it is that people are spending looking at this. Certainly, an average completely throws out this stochastic nature that sometimes it'll be longer and sometimes it'll be shorter. And we should probably actually consider this as we actually simulate. We shouldn't fool ourselves that things are precise. Oh, people spend an exact amount of time per summary. Obviously they don't. It varies, and so we should capture that variance in our models. But what we're going to do today is we're going to keep things simple. So we are going to look at producing just an average. All right. So to produce an average for a single user, what we did is basically, so we did not have an eye tracker. We've got we know they're working down this rank list of results. And remember also, so we've got this, they're rank 1, 2, 3, and it keeps going. And they can say the next 10 results and the next 10 results. So this list goes on and on and on. Every time that they're on this page, we're keeping track of the amount of time spent on that page. So when they click and they go to view a document, we're not counting that time viewing the document here. It's only the time that they've got this page up. They're in a lab controlled study. We know they're not like looking at their watch on their phone. They're not reading another web page. The only tasks they're given is to work on this and find relevant documents. So the time they spend here should be time that they're spent evaluating and thinking about this page. And so what we basically do is we go, oh, okay, this is, we saw them, the lowest rank that they ever clicked. You know, to click on something means you looked at it, because to click you have to actually see it. So we know that they actually viewed that. They might have viewed things after that, but we're positive that they viewed that one. And also based upon our simplistic model and our understanding of the way users behave, they probably viewed all the summaries prior to this as well. All right, So what we do is we know that we've got a maximum rank, which we will say is the last clicked summary. All right, and this is, it's at rank, and we'll use rank K to represent the rank that they did this at. So for every single user, as on each task that they have, we know the amount of time they spent on this page, and we know the maximum rank that they ever clicked at. All right, so it's pretty easy then to go ahead and say that the average time on a summary is equal to the total time spent on the search engine results page divided by K, the maximum rank. Easy, absolutely. All right, now what gets a little bit more complex is deciding how to put this into the overall model that we're going to use. There's a dilemma here, because when we model our users, and we're actually not modeling it in this first model that we have, it's not actually an individual model, individual user we're modeling. We're trying to have a model that's a prediction of the population performance. And so again, it's like using the average amount of time. But if some people are driving that model and working faster than others, or some of them, you know, they have other behaviors, that needs to be reflected overall in these times that we produce. So we care about the people who basically end up doing more in the same amount of time. Okay, we need things to be proportional so that at the end our actual prediction is reflective of what a population of users would do, rather than just individually predicting one single user. In that work that I talked about, the stochastic simulation, in that approach, actually what we do is we individually model each of the 48 users, and we have an individual model for each user, and then we simulate all of them working, and we produce a distribution of behavior. And that's actually a bit easier because, yeah, whatever your model that we've simulated for that user does, it just goes into the overall behavior of the population that we're simulating, and out we get our measurements of overall performance. Here in this one, we're building a model basically to predict a population, and so that our average needs to reflect that different users do a different amount of work. So to write this out, so some users reach a greater rank K. And I've said this, that we want to predict behavior for our population of users. So the model needs to weight these various users. So basically you end up with a weighted average. So we're going to say that our time on our summary is a summation over our participants P Now, we had people work on multiple tasks. So we're going to have a summation over all their tasks. And SIP, this is the ith time spent by participant P on the SERP. And then we were dividing by MP, and this is the max click rank of the participant P. So we've got participants in our subject. All right, so this is the amount of time spent looking at the SERP. They've done this over numerous times. We're going to sum up all those times, find out what the average amount of time. Oh, sorry. This is, each one of these is a viewing of the search engine results page. Let's be clear about that. So these are all the individual times they spent looking at that search engine result page. And we have that over, okay, and then we're going to divide it then by the maximum rank seen by the user. Then what we'll do is we'll have that maximum rank. We'll again sum up this M of B here. This simplifies down to just simply be 1 over the sum for the maximum for the participants here, and then a summation over the participants and a summation over all the times viewed and their times on those SERPs. All right. I don't know why I look at that now and I wonder about it. I'll come back to this if I find that my understanding is faulty. I think, or maybe there's a mistake in my paper. That's after all these years. Maybe looking at it now, I see something that doesn't seem quite right. Anyways, this ends up with a final value when we run it for the real data of 4.4 seconds. Okay, so that's what our estimate of the time spent looking at each SERP is. 4.4 seconds. But the key idea there really is not so much to worry about all this weighting. The key idea is, yes, look, we can estimate the amount of time spent looking at each summary. All right. Then, okay, let's talk about time spent viewing. Well, let's actually not get there yet. We were just working on this first state. All right, this amount of time spent looking at a summary. Now let's look at them deciding to click or not. All right, so again, there's lots that we could actually consider to model, but let's keep it simple, okay? So our simple model is going to be to model this decision of clicking or not as a probability of clicking given known relevance of the document. And this is why I took that interlude to talk about test collections. So we have this test collection, and we're using one in this study, and our assessors have judged the relevance of those documents, and they've told us what the known relevance is. Now, we have different people in this user study. These are not the original people who were Trek assessors. And so their decisions about whether something's relevant or not, or deciding to click on or not, is not going to be exactly the same. But this is a very good signal that we have in our data. We have these assessors. They said, yes, this is a relevant document. And we could use that as a way to estimate the probability that someone will actually click on it. That will give us a good signal about whether or not, because we know from all of our observations of users that they are more likely to click on things that we already believe to be are relevant. They follow what we think they're going to do. It's not perfect. They don't 100% click, but they are more likely to click on the things we think they are relevant than the things we think are not relevant. All right. So keep it simple again, and we're going to compute this for all users, what this probability is, and then we're just going to average it. All right. So we're basically computing the probability of clicking. And when we say this is given that. So this is the notion of given that. It's a conditional probability. Given that the document has been judged as relevant, this ended up being 0.64. And then the probability of clicking, given that the document has been judged to be not relevant, this was found to be 0.39. All right. And so, yeah, so this generally follows what we expected. All right, so this gives us probabilities about whether clicking or not on individual summary based upon the known probability of relevance. When I continue with the lecture, we'll talk more about how to do the time to view the document and whether or not on the decisions of it's relevant or not. And then we'll also start to talk about getting to what how do we estimate and deal with the time? Okay, and put it all together then to get a final effectiveness measure using this model of user behavior. So that's where I'll continue. I mentioned some reading. So I have uploaded the SIG-IR 2012 paper to the readings, and it notes that you should read sections 1, 3, 4, and 5, but you can skip that last part, which is 5.4. You don't need to look at that. This will cover all the way through an introduction, the model, calibration, and validation. So this is the reading that goes along with the lectures we have here. And in the search engines book, you should be reading chapter 8 now, and this is the evaluation chapter. All right,